Good morning, 8th grade. Today we are beginning Module 6, and this one is all about linear inequalities, and that's what this unit is. So, the first module, Module 6.1, solving one-step inequalities. And let's look at our learning target. I can graph the solutions of an inequality. I can solve linear inequalities by using addition, and I can solve linear inequalities by using subtraction. The vocabulary is inequality, and we're also going to talk about set builder notation. So let's first go ahead and discuss what is an inequality. Okay? So there are several types of inequalities, and what is an inequality? It is a mathematical sentence that contains the symbols, these symbols. Okay, so we have less than, or equal to, greater than or equal to. We also have what is not equal to. So these are all inequality symbols. And an equality compares the value of two numbers or expressions using these symbols. And we've also done, even in 6th grade, when we say at most, at least, maximum, minimum. So that's telling you it's all an inequality, and how we are supposed to write it depends on the word that is attached to that inequality. So let's first go ahead, and we are going to graph the solution set. Okay, we're going to graph the solution set of y is less than equal to 4. So if I'm graphing the solution set, let's look at this. I always ask you that you need to first give values to that y. Okay, so if I look at what is equal to 4, because this is less than equal to. Okay, so what is equal to 4? And that would be 4. What is less than 4? And so I have 3, 2, 1, etc. and to the negative. Right? So that's the first thing that we need to do. Next, of course, we are going to make a number line. Okay, and then it's saying less than or equal to 4. So, and then of course we have negative integers over here. So we know that 4 is included in this data set. So that's why I'm going to go to 4. I am going to make a circle, and I'm going to close it. So this is a closed circle. And the reason I'm closing the circle is because 4 is included, because it's saying less than equal to 4. And then everything to the left of 4 also is a solution to this inequality. So if I am, once again, the dot at 4, this over here, the closed circle or the dot is showing that 4 is also a solution to this inequality. And the heavy arrow pointing to the left shows that the solution includes all numbers less than 4. Okay, let's do graphing of a solution set where, let's do one, and I'm going to just put it this side. Okay, let's do one where we have y is greater than 1/2. Okay, so if I'm saying y is greater than 1/2, what's the number greater than 1/2? Okay, so bigger, that means greater than 1/2, we have 1, 2, 3, and so on. So I know that this graph is going to be going towards the right. And that's the first thing, always give a value. Otherwise, very often you go ahead and you graph in the incorrect direction. So make sure you're giving that value to your variable. So now, all I'm going to do, since I know it's going to the right, and we have 0, 1, 2, 3, 4, etc. So now we need to see if it's greater than 1/2, is 1/2 included in the solution? No, because it's not saying greater than equal to 1/2. So that is why 1/2 is not going to be a solution. So what we do is, we know that 1/2 is going to fall between 0 and 1. This is my 1/2, right? So what I'm going to do is I am going to have an open circle. Open circle. And then everything to the right of 1/2 is going to be a solution to this inequality. So if I ask you, what about 3/4? Is 3/4 a solution? Is 3/4 to the right of 1/2? Absolutely. So that is a solution to this inequality. All right. Now we have not closed the circle. So look, this is an open circle. This is an open circle, or it's an open dot. And the reason we say that is because it is not saying greater than or equal to. So since it's greater than, it's going to be an open circle. That once again means that 1/2 is not a solution to this inequality, but everything greater than that is. On the other side, let's look again. If it's y is less than equal to 4, 4 is also a solution, as well as everything else which is less than. That's why that is a closed circle, and everything to the left of that is also a solution to this inequality. Okay? Now, let's go ahead and we are going to write an inequality that is being represented by the graph that I have over here. So let's look at this graph. Okay? Now, we can see that in this inequality, what do we have? We can see that the endpoint is shown as a circle. Okay, and we can see that this circle is an open circle. It's an open circle. Okay, it's not closed. That means 1 4/10 is the endpoint is shown with a circle at 1 4/10. So 1 4/10 is not included in the solution, and the inequality must be obviously is going to the left, so the numbers are smaller than 1 4/10, right? So therefore, what is this going to be? We are just going to say x or a or b or whatever you want to call the variable, and that is perfectly fine. And let's say we are going to say x. So x is going to the left. So we know the numbers on the left of the number line are smaller. And the more to the right on the number line we go, the numbers are greater. So if I'm looking at this, I know that x is going to be less than 1 4/10. So here is my inequality that I've written out. So if I look at this, is 1 4/10 included? No, it's not a solution because it is an open circle. And then anything which is less than 1 4/10 is a solution to this inequality. Okay? Let's look at this problem. We are writing an inequality that represents the graph. So now we are going and looking at, first and foremost, where is my dot? And I can see that it is here, and this is a closed circle. Since it is a closed circle, that means -10 is also a solution to this inequality, and everything which is greater than that, because the graph is moving to the right. And so therefore, x is greater than equal to, because it is a closed circle, to -10. I can also write it like this. So -10 is going to be what? Less than equal to x. So as long as the inequality is facing x, that means x is greater. Okay, so either of these methods, how you write it, is perfectly fine. Okay, now let's talk about addition and subtraction properties of inequality. So now let's go ahead and talk about addition and subtraction properties of inequality. If I am adding the same number to both sides of the inequality, it's not changing the inequality value, right? So if I have a problem like x minus 10 is less than 15, basically, I solve it the same way I have solved equations, but the only thing over here now, I don't have an equal to sign, so it's an inequality. So inverse of subtraction is addition. So I would add the same number to both sides of the inequality, and that is the addition property of inequality. If I have addition, on the other hand, well, this is all subtraction, but let's say I had addition on the other, one side, then what is the inverse of addition? It would be the subtraction property of inequality, and then I would subtract the same number from both sides of the inequality. How about multiplication and division? What's the inverse of multiplication? Inverse of multiplication is division, so I would use the division property of inequality. And the inverse of division is multiplication, so I would use the multiplication property of inequality. Once again, this is a review from what we've done since 6th grade. And so now let's quickly refresh our memory and apply those properties when solving this. One additional thing we are going to learn is this vocabulary word which says set builder notation. So look how I have written the set builder notation at the top. Okay, and when we are solving inequalities, you can write the solution set in a more concise way by using set builder notation. So instead of saying all of these are the values, all you can do is write it in this format, and this is called the set builder notation. And what this basically means is, for example, this one. What this means, this represents the set of all numbers x such that x is greater than or equal to -4. So it's just telling me this is a set of all numbers x such that x is greater than or equal to 4. And this is a set builder notation. Okay, so let's go ahead and we are going to solve these, and then we are going to put it in the set builder notation form. So if I look at x minus 10 is less than 15, okay, and that is my original equation, inequality, sorry. So what is the opposite of subtraction? I am going to use what? The addition property of inequality, because opposite of minus is plus, and I am going to add 10 to both sides of the inequality. Whatever I do on one side of the inequality, I do exactly the same thing to the other side of the inequality. So I am using what? The addition property of inequality. Okay, so that's what this is. And then what is 10 minus 10? This is going to cancel each other out. And so I'm left with x is less than, what is 15 plus 10? I get 25. Okay, so x is less than 25. So what is my solution set going to be? So I'm going to write the solution set now. Okay, so my solution set is written with these kind of braces, all right, where we have x, okay, such that all values of x is going to be less than 25, which will be a solution to this inequality. Okay, so once again, it's going to represent a set of all numbers x, okay, such that x is less than 25. And that is how you write a solution set. Let's try the other one. Okay, now in this case again, I have negative 9 plus b. So what is the inverse of minus? It is addition. So I am going to add 9 to both sides of the inequality, because once again, whatever I do on one side, I do the same thing to the other side of the inequality, and we are using the addition property of inequality. So I'm going to do 9 minus 9 is going to cancel each other out, and I have b is less than equal to, and what is 16 plus 9 gives me 25. Okay, so in this case, what is my solution set over here? Okay, my solution set is going to be b, where b is going to be less than equal to 25. And so here is how I write out my solution set. Okay, so basically it's just telling me this is a set of all numbers b such that b is less than equal to 25. And that is my solution set for this problem. Okay? All right, so I have put 2 more examples on the board. In one, I have x plus 24 is greater than equal to 61. In the other one, I have put an inequality where I have variables on both sides of the inequality. So let's start with solving the first one. Okay? As we can see, this is addition. So what is the inverse now? So we are going to use the subtraction property of inequality. So the subtraction property of inequality is being used now because subtraction is the inverse of addition. So I am going to subtract 24. Whatever I do on one side of the inequality, I do exactly the same thing on the other side. So minus 24. 24 minus 24 cancels each other out, and I am left with x is greater than equal to, and 61 minus 24 is going to give me 37. Okay, so what is my solution set going to be? So I'm going to write it like this. Here is my solution set, and I have x is greater than equal to 37. And there is my solution set written out for this value. Okay, which basically what is that? Set of all numbers x, set of all numbers x, so that or such that x is greater than equal to 37. And that's what this means. Okay, now let's do the one where I have my variables on each side. Okay, so I'm going to write out my original inequality, and then I am going to, as we know, we've got to put the like terms together. So I'm going to put the 9y with the 10y, because that's the only way I can add or subtract is when I put the like terms together. Okay, so this is my original equation. I am going to subtract 9y from both sides of the inequality. Okay, and I know that 9y minus 9y is going to cancel each other out, and then I am left with 3 is greater than equal to, what is 10 minus 9? And I just get y. 10y minus 9y, I get just y. So since 3 is greater than equal to y, this also means what? This is the same thing as writing y is less than equal to 3, right? I've just put this side, but don't forget then that because this is 3 greater, yeah, is 3 greater here. So it depends on where the inequality is facing. So I can write the solution set as this. Here's my solution set. I'm going to write a set of all numbers y where y is less than equal to 3. And then of course, this is how you show the set. Okay? And that is how I solve when I have variables on both sides of the inequality. Okay? Remember, combine the like terms and then you solve it. So let's do a word problem for inequalities. So let's look at this one. It's talking about data usage. Hassan's wireless contract allows him to use at most 5 gigabytes of data per month. So at most, so I'm just going to start writing out an inequality. So at most, which is 5, at most means it is the maximum amount. It is the maximum amount. And that's what at most means. And that means everything else is going to be less than that. So this is the greatest amount. So everything else at most 5, that means 5 is also included. Okay? And then it's saying that at this point, Hassan has used 3 7/10 gigabytes of data. Has already used 3 7/10 gigabytes of data. How many gigabytes of data can Hassan use during the rest of the month without exceeding the maximum allowance? So, when we are talking about how much more can he use, so this is, let's see, what did it say? How many gigabytes of data? So we are going to call gigabytes G. Okay, so I'm going to say he has used this much, plus he can use a certain amount of gigabytes, and that should not exceed 5. Okay, because 5 is the maximum, because it is, what was the word used? At most. And that means this is the maximum amount that he can have. So here is my inequality written out. And then I'm going to go ahead and solve it. And so as I can see, I have 3 7/10, and this is a positive. So what is the inverse of addition? Is the subtraction property of equality. So I am going to subtract 3 7/10 from both sides of the inequality, and this 3 7/10 minus 3 7/10 cancels each other out. So I'm left with G is less than equal to, and 5 minus 3 7/10 gives me 1 3/10. So what is my solution set? My solution set is going to be G, set all values of G, where G is less than equal to 1 3/10. And so here is my solution set. So Hassan can use up to 1 3/10 gigabytes of data without exceeding his maximum allowance. Notice that negative numbers are solutions to the inequality, but they are not viable solutions to the problem, because Hassan cannot use a negative amount of data. Okay, so he cannot use a negative amount of data. So that is why, even though it is a solution to the inequality, we are not going with negative numbers over here. So now let's talk about a few problems where we are doing multiplication or division properties of inequality. So let's look at this problem over here. And it's saying Alyssa has read approximately 1/4 of a novel. Of means what? Multiplication. Okay, so we are going to start writing out an inequality. Okay, so it's saying 1/4 of a novel. If she has read at least, now think of the word what we have here, at least 112 pages. So that means minimum amount. Okay, so 112 is the minimum amount. So this is at least. Okay, that means this is the minimum amount. This is the minimum amount. Okay, so if it is saying at least, that means 112 is the least amount and everything else it's included and everything else greater. And so 1/4 of a novel, 1/4 n. Okay, so I can see that my coefficient is 1/4, or this is 1 divided by 4. Right? And so what is the inverse of division? It's multiplication. So I am going to multiply both sides of the inequality with 4. Because 1/4 means division, and what is the inverse of division? Is the multiplication property of inequality. So I am going to multiply both sides by 4, and this is 4/1. So 4 divided by 4 gives me 1, and 1 times n is going to give me n is greater than equal to, and then I have 112 times 4, and I am going to get 448. So once again, there are at least 448 pages in that novel. Okay, and that's what this means. And here's another question. We are writing and solving an inequality. So let's look at this. Electric car. For every hour X that Eva's electric car charges, she can drive the car 7.5 miles. Eva needs to drive at least, that's the minimum amount, 60 miles tomorrow. So what inequality represents the situation in terms of X hours? And what is the least amount of time that Eva will need to charge her car? So it said at least 60. That means everything else is going to be greater than or equal to 60, because this is at least. That means it's the minimum amount, right? And then it's saying for every hour X that Eva's electric car charges, she can drive the car 7 5/10 miles. So 7 5/10 miles, and then how many miles do we have? Times X. So here is my part A. What inequality represents this situation? So this is 7 5/10 X is greater than equal to 60. And then we are going to go ahead and solve it to find the least amount of time that Eva will need to charge her car. So we know this is multiplication. What is the inverse of multiplication? Is division. So I am going to divide both sides of the inequality by 7 5/10, 7 5/10, and this gives me 1, and we are left with X is greater than equal to 8. So this is going to be what? 8 hours is my answer. 8 hours is my answer, because it's saying what's the least amount of time. So 8 is going to be the least amount of time. 8 hours is the least amount of time that she will need to charge the car. And that's how we solve inequalities, word problems with inequalities. All right, so we are going to go and solve these two inequalities over here, and then we are going to graph it. And then, of course, talk about what the solution set is going to be. So the first one, this is -2/5 X is less than equal to 11. Okay, so there are a couple of ways to do it, but we know that we have -2/5. So what can I do? I can just divide by 2/5, right? And then what is, when you know that when you are dividing fractions, keep, change, flip, right? You keep the original fraction, change the division to multiplication, and then you flip the second fraction. So if I was saying divided by 2/5, it would actually be what? times 5 over 2 because you are multiplying with the reciprocal. So I'm going to go ahead and just do that. Okay, so I'm going to take the original inequality less than equal to 11, and I am going to multiply with the reciprocal, okay, times 5 over 2. Whatever I do on one side, I do exactly the same thing on the other side. And so 5 divided by 5 and 2 divided by 2, which is 1, and that is negative 1. So I get negative x is less than equal to, and then I am going to do 11 times 5 divided by 2 is going to give me 27 and 5/10. Now watch, my variable cannot have an x. So all I need to do is I am going to just multiply with negative 1 on both sides. And so what actually happens here is this is going to become x, because I need to have my variable as positive. And then I'm going to take this and I am going to flip the inequality. Okay, so this becomes this. So instead of less than equal to, x is greater than equal to, and then I am going to, of course, times, this becomes negative 27 and 5/10. So here is my answer. Now, you can also do another thing. When I was doing the reciprocal, I can straight up just, like it's negative 2/5, so I can do times negative 5 over 2. Okay, so if I do times negative 5 over 2, I will get positive over here, and this would be negative because times negative, right? This is what I mean. Look, I can do negative 2/5 x is less than equal to 11. So then I'm saying I could also do this. I could straight up do negative 5 over 2 times negative 5 over 2. Okay, and then I would, since I am any number that I am multiplying or dividing by the inverse sign, my inequality flips, and we've already done that in 7th grade. Okay, so negative divided by negative, this is going to become positive. We know that. Okay, so this becomes positive, flip the inequality, and this becomes this. Negative times positive is going to give me this. So this is what I meant. Either you can do it this way or you can do it this way. It doesn't matter. And so now let's look at my solution set. And my solution set is this. X is going to be greater than equal to negative 27 and 5/10. So it's a solution X where is going to be greater than equal to negative 27 and 5/10. And so now if I am going to graph this, I can have a graph. Just trying to see if you can see what I'm doing. Okay, now we know that this is in the backward distinct direction. Remember, 0 is your mirror. Everything to the left is a reflection of what's to the right. Okay, so I have negative 25, negative 26, negative 27, negative 28, negative 29, negative 30, etc. So if I'm saying negative 27 and 5/10, that is going to fall between negative 27 and negative 28. Okay, so this is my negative 27 and 5/10. And we know that it's equal to this, so this is going to be a closed circle, right? And then it's greater than, x is greater than, so everything to the right on the number line is greater. So my arrow is going to go in this direction. That's my solution of this inequality. And that's how we solve this. So either way, please remember, we cannot have the variable as negative. We've got to change it to positive. And so that is why when we are changing the variable to a positive, we are flipping the inequality. Because whenever I divide the values here by the opposite sign, my inequality is going to flip. Whether I divide or I multiply, both of those situations, the inequality is going to flip. Okay, if I'm dividing by the opposite or if I'm multiplying with the opposite sign. Okay, so this is how we do the first one. Let me go ahead and work out this one. So I am going to go ahead and remove this part. Okay, and then let's do 20x is less than 4. So now we are doing it's a multiplication problem. And so once again, what is the inverse of multiplication is division. So I am going to use the division property of inequality. So I am going to divide both sides because it's 20x. I'm going to divide both sides by 20. Okay, so if I divide both sides by 20, here we go, 20 and 20. 20 divided by 20 is 1, and 1 times x gives me x is less than, what is 4/20th? 4/20th, we're going to put it into the simplest form. So x is less than 1/5. All right, and so my solution set is going to be this. All right, here is my solution set. And then if I am graphing this, I know this is 0, this is 1, this is -1, -2, etc. Okay, and then I said it is less than 1/5. So all I can do is this: 1, 2, 3, 4, 5. Okay, 1/5, 2/5, 3/5, 4/5, and 5. So I am going to make this part, obviously that is my 1/5, right? And so since it's less than, is 1/5 included? No, it's not a solution. So I am going to have an open circle. So if I have an open circle, here's my open circle. And then everything to the left is a solution to this inequality. Everything to the left is a solution to this inequality. All right, let's do one last problem. So now we are solving an inequality with a negative coefficient. Okay, so if I'm saying -13z, that means -13 times z, right? What is the inverse of multiplication? We are going to use the division property of inequality, and I am going to divide both sides by -13. By -13. And -13 divided by -13 is going to give me 1. And what did I say would happen when I divide a positive by a negative or a negative by a positive? What's going to happen? This is, so what happens now when I divide a positive by a negative? My inequality is going to flip. It's going to become this way. And so therefore, I have z is less than equal to 117 divided by 13 is 9. But now we are dividing opposite signs, so this is going to be -9. So what is my solution set? My solution set is this. Okay, and here is my solution set. And then I am going to go ahead and graph this. And I know that it is saying -9, right? So we have -8, -9, -10, -11, -12, -13, etc. And we know that -9 is included. It's also a solution to this inequality. And so I am going to go to -9 and I am going to do a closed circle. and then everything less than that is also a solution to this inequality, and that's how I'm going to graph it. Everything to the left is also a solution to that inequality. And basically, that's what solving one-step inequalities is. I think the only new thing that you have learned is the set builder notation, but everything else about solving one-step inequalities we have done in 6th grade and 7th grade. So this is a refresher for what is more to come. And that concludes Module 6.1. Have a fantastic day, everyone.